Good evening, ladies and gentlemen. I'm Mahendran Prashantham, President of ISACA Sri Lanka Chapter. On behalf of the chapter, I would like to welcome you all and thank you very much for participating in this webinar. Since there are members from other professional institutes, let me start off with a brief introduction about ISACA. ISACA, which was previously known as Information Systems Audit and Control Association, is a worldwide association especially for cybersecurity, governance, and audit. It started in the year 1969. Currently, there are more than 145,000 members worldwide practicing in 180 countries. In Sri Lanka, ISACA has been in existence since 1996. We have approximately 250 members, and ISACA is associated as an association of the Companies Act, and it is also the professional chapter of FITIS. So the aim of the local chapter is to sponsor webinars like this, seminars and chapter meetings. In the recent past, we have been very active. We have been conducting events for more than 200 CPE points annually. Last year, we touched 400 CPE hours. And the ISACA Sri Lanka chapter also has 4 university student chapters, namely UCSC, NSBM, SLIT, and University of California. So in recognition of our dedication and good work, we have won regional awards 3 times, 2013, 15, and 16. And to make it bigger, in 2022, we won the Outstanding Chapter Award, which was held in USA this month. So these are the certifications of ISACA. So unlike previously, some of these certifications, you can be a student member or an associate. Still, you can pursue some of these certifications. But obviously, some of the certifications, you need to have experience. So as I mentioned, we have conducted many webinars, and we have also started with few physical events. These are some of the events what we have been conducting for the last 6 months. Some of these events are conducted by ISACA Sri Lanka chapter, some along with our MOU partners. So these are the MOU partners, supporting organizations of ISACA Sri Lanka chapter, namely FITIS, Computer Society of Sri Lanka, SLASCOM, BCA Sri Lanka, ISC Squared, CA Sri Lanka, CFA Society, and IAP. These are the sponsors: Synetcom, LOC Technologies, and Cyber Labs. Okay, so today's topic is something which is very important: Windows forensics investigation. Right, so it's a technical topic. So all our events are usually technical, as well as some are non-technical, but this time we thought let's have a more technical topic. And the speaker for today is Ravindu Meegasmulla. So before I introduce him, this is a webinar which is worth 1.5 CP hours for different MOU partners. Don't worry about your CPD or CPEs. That will be sent to the relevant coordinators. So you don't need to type in your CPD. Please don't type it on the chat window. But if you have any questions, please feel free to type in those questions in the chat window, and the speaker will try his very best to answer all the questions. So let me introduce the speaker for today, Ravindu Meegasmulla. Ravindu obtained a BSc Honours in Computer Science degree from Staffordshire University in UK, and a MSc in Digital Forensics and Cybercrime Analysis from the same university. He has worked as a forensic lab assistant in the Staffordshire University for 5 months. Currently, he is carrying out information security related tasks at Sri Lanka CERT since 2015. He is in charge for conducting digital forensics investigation, performing technical network application security assessments, and also activities related to information security. He has obtained certified ethical hacker, computer systems, Red Hat certified systems administrator, computer hacking forensics investigator, Red Hat certified engineer, and mobile security specialist professional certifications. As an information security engineer, Ravindu has conducted over 100 digital forensics investigations. So, the ideal person to talk about Windows forensics investigation. So, with that introduction, I'll hand it over to Ravindu. Ravindu, over to you.
Right. Thank you so much for that introduction. Let me share my screen. Right. Right. Is the screen visible and am I audible properly?
Yes, you are audible and the screen can be seen. Yes.
Right. So thank you so much, Isaka, for having me here today. It's a privilege to be here. So as Vajan said, this is going to be a bit technical, but I'll try to put it in a layman term so that everyone can understand. So I will not going to talk about myself. So this is the agenda for today. I'm going to talk about Windows Registry and how investigation can be done using the Windows Registry itself. I'm going to briefly talk about the structure of the Windows Registry and how can we use to view it and some other analysis tools that can be used. Before we move into the topic, I want to tell you that deep analysis of connected USB devices is not covered today because of the time frame. But obviously, I'm going to show you how you can find out connected USB devices. I think that will help you as well. So what is Windows Registry? For me and for any network administrator, Windows Registry is somewhat a scary place. It contains lots of information about the system itself. It contains information about the services and activities which done by users. So there are a lot of information, and registry tend to change whenever a new Windows operating system released. So I don't think there is a person who knows A to Z in Windows Registry. But the best practice for an investigator or a network administrator, if you come across an incident or if there's an investigation, always know what you are looking for, or what you need to look at in the Windows Registry before you go into it. Have a plan in your head, so that will be easy. It will save time, and otherwise you will end up with finding nothing, and sometimes you feel lost, right? So Windows Registry is a hierarchical database, and as I said, it contains settings, configurations of the computer, and it have information about the hardware. It has the information about services and some element of security and users. This particularly Windows Registry boots up when the operating system starts, and there are 4 main hives that be active when the operating system starts. First one is the software. It basically have the information about software that are installed on the system, and also sometimes software that used to install on the system, used to be on the system as well. And the second hive is the system hive, which has the information about the overall system, configuration, settings, and information about the hardware. And then the security, which keep the information about on settings, security settings that user has implemented, and also the operating system which are using. And then the SAM hive, this is basically keeping the information about the users itself. And there's another specific file, we call it ntuser.dat. This will be available for every user in the system, the root directory. And whenever the particular user authenticated to the system, ntuser.dat file related to that user will be will come alive, right? So there are two ways of viewing the registry. One way is when the machine is up and running, you can use the famous regedit command, and I put a screenshot there. And then the second method is viewing the registry using any digital forensic investigation tool. And the four main hives that I talked previously, they are located in the system32 config file. If you go there, you will find the system, software, security, and the SAM hive. This is how it look like when you look at using a forensic tool. In this case, I'm using a tool called Encase. For some people, it can be confusing. So what I've done here is I created a table, and I'll show and it represent where the information coming from when you are looking at using the regedit command when the machine is running. So basically, system, software, security, the all information will be showed in the HK local machine when you are viewing it using regedit command. And then the SAM file will be used to pull information to the HK users. And there's another one called BCD, boot configuration data, that can be found in the HK local machine BCD. And HK current users, that information is coming from ntuser.dat file. So this is the structure. This is when you are using the regedit command, the registry viewer. So the first layer of the folder, we call it as a registry key hive. And then the next layer, we call it registry keys. There can be many registry keys. And then there can be registry sub keys. And the right side to you, you can see the value for each registry sub key. The values can be held in the registry keys and also sometimes in the registry hives. So values can be seen on the right hand side. And these are some of the tools that can be used for our incident handling and also when you're conducting investigations. Regedit, obviously, a free-to-use tool which comes up with, by default in Windows operating system. Reg.exe is the same. Autorun exe. There are some scripting tools which can be used to view the registry. And there are other tools called RegShot and RegMon. These particular tools are mainly used when you are doing dynamic malware analysis. RegShot is basically used to compare two snapshots of the registry and see the see the difference between the first shot and the second shot. And the RegMon is basically to monitor the registry. And there are some built-in tools. If you take Encase, FResponse, FTK, they have built-in tools to analyze the registry. Of course, these tools are commercial tools. And the famous RegRipper, again, it is available if you're using Autopsy. It is available as a plugin. And there's another one called RIP. It's a Perl application. And then another one called RegSlack. So when do we use registry analysis? Well, it depends on the case. It depends on what you are looking at and depend on what you are after. But mainly when you are doing network-related investigations, it will help. If there are incidents about a malware infection, it helps. And if you are looking at suspicious user activities, the registry is a good place. and there are many more. Right, let's go back. Let's dive ourselves into some of the investigation techniques and investigation things that as an investigator do. The first thing as an investigator is to identify the time zone, because if you are doing your analysis or investigation using a different or a wrong time zone, all the information that you are providing, all the evidence that you are providing in your report will be invalid, because that's not the current timestamp reflect in your report. So the first thing is always to find out the correct time zone, and that is located in the system hive. And once you go into the system hive, there's a folder called control sets. Well, this control sets keep the information about the devices, drivers, and services of the system, right? As an investigator, it is crucial to identify the current running control set. There will be more control set, but in this picture you can see only 2. There are instances there we saw 4 control sets. So we need to identify the current control set, or the correct control set that particular machine is used to run. Obviously, the second control set will be the backup of the first one, and the values that are stored there in Little Indian format, and you need to convert it to 32-bit integer, and the values are displayed in hex values. To identify the current control set, you need to go to the select folder. Once you go to the select folder, there will be a value called current. If you look at the current folder, you can see the current control set that which this application is using. And here it's control set 1. So once the investigator identified the current control set, then only you can go in and see the relevant information. So you go to the relevant control set. In there will be a place called control. In there will be a place called time zone information. Once you go to that place, there will be a value called time zone key name. There you can see in this example it says Pacific Standard Time. Once you identify the correct time zone, you put that into your investigation tool, so that all the timestamps that you produce will reflect this timestamp. And the next bit is to identify the last shutdown time period. Again, you have to identify the control set, and then there are a place called control, and then time zone information, and then go to Windows. And there you can find a place, something called shutdown time. Again, you have to decode this value. I used open source tool called Decode. This tool is specifically designed to decode date and time values. So once you put the values you find, and you have to put the decode format to Windows 64-bit hex value format. It's a Little Indian format. Once you've done that, you get the correct time period, and here it says somewhere 2011. As an investigator, as a network administrator, this information will come to you within a click of a button. But if there is someone who's ready to challenge you, if there's someone asked to cross-examine you, you need to know where this information is coming from. Whether you are using a tool or not, you need to know this tool get the information from this place. So that's why I'm putting this here. Next one is identifying the operating system and also the install date and time of the operating system. Again, it can be found in the software hive. And if you go to this location, Microsoft Windows NT current version, and the product name. Product name will be the operating system name, and here it says Windows 7 Enterprise, and the current version will be the Windows NT version. So in here it says 6.1, and you can get the install date here as well. It's funny that Windows keeping the information in the Unix date format. So whatever the value you get, you have to decode it according to the Unix date and time. Next, we are looking at the users in the system. So our goal is to identify the domain users and local users in the system. Before we go into users, we need to understand that in a Windows operating system, they have a mechanism called SID. We call it security identifier, that is used to identify a user in the system, right? Last bit of the SID is called the RID, which stands for relative ID. That is unique to the specific user, and the first part is unique to the computer itself. So by default, administrator has the RID of 512. Guest will have the RID of 501, and the custom users will have RID from 1000 onwards. And if you see a user, let's say, which has the same RID 1000, but the first part is different, so that is an indication it is a domain user, someone from outside connected to this machine. It has the relative ID of 1000, but the first part is different because it is unique to each machine. So if you see two users with the same RID, but the SID is different, that means two users. One is the local user, the other one can be a domain user. So this is how the SAM hive is look like. Once you go into the SAM hive, there will be important two folders we call users and names. In the users folder, there will be folders with hexadecimal values. So these values are basically representing the RID in hexadecimal format. So for the example, if you look at the folder name which has 3E8, if you convert it to decimal, it comes as 1000. So all the information about the user which has the 1000 RID will be there. And if you go to the names folder, Sam Allen will be the user. So this is how it look like. And HK users, if you if you use the registry editor, if you go to the HK users, this is how it look like. And if you want to find SIDs of the users in the system, if the machine is up and running, you can use below command to get the SID. Right. Next, let's move on to identifying mounted devices and USB devices. So our goal here is basically to identify mounted devices, gather more information about them, finding the hardware, and map the hardware with the USB devices found in the crime scene. The hardware is kind of important because if you take what do you call well-known brand like Kingston, Imation, so on and so forth, they have a system where the hardware ID is unique. So if you're able to identify USB devices which is connected to a particular machine, and if you find USB devices in a crime scene, if you want to map them, see whether the person has used those USB devices in this particular system, you can use the hardware ID to correlate it. And there's a tool called USB Treeview, which is an open source tool, which is freely available. You can use that to identify the hardware ID. So let's see. Mounted device, the information about the mounted devices will be available in the system hive, and there will be a specific place called mounted devices. Once you go there, you can see there are a lot of DOS devices. In here, if I select, I have selected DOS devices J. When you select that, you get to know the name. It says Kingston Pro Data Traveler 2.0. And after that, you will see a string of values. We call it a GUID, which is unique to this particular device. This is how operating system track the particular mounted device. So once you identify the GUID, you can get more information. So that information can be get from the system hive. Again, you need to identify the current control set. Then in the enum and USB store, if you go to the USB store, there will be a folder with the GUID that we have found earlier. If you go to that folder, you will be able to identify information like hardware ID, friendly name. Friendly name is the name that when you put when you're formatting the USB drive, or when you're formatting external hard disk, the name that you're putting it will be displayed in the friendly name tag. So this is how you get more information, and to get information about the time period or the timestamp, we have to do a lot of other investigations, and we have to correlate other information with this. So I will not go into that today. And the next one is network related investigations. So our goal again here is to identify network interfaces in the machine, and identifying IP addresses, DHCP server IP address, and again lease obtain time, lease terminate time, etc. And identifying SSIDs or network profiles, and identifying MAC addresses, and then wireless access point. These information can be taken get from the Windows registry. So let's see how we can do that. Again, to identify network interface cards, you have to go to the software hive, and then Microsoft, Windows NT, current version, and then network cards. You will see the network cards there. If I select, I have selected number 4 in here. It says it's Intel dual brand wireless. So this is the wireless interface, and there will be again a GUID, which is again unique to that particular network interface. So we can get more information by go to the below location, current control set, services, TCP/IP, parameters, interfaces. There you will get a folder specifically for this GUID. If you go inside, you can get more information like DHCP IP address, DHCP server, lease obtained time, lease terminated time, so on and so forth. Right. So this is some of the example. Again, the times you need to convert them to Unix date and time. Then only the correct time will be showed. So we have identified, we can identify the time frame that particular interface is connected to the network, but we are still we still don't know the what you call the network profile or the network connection name. So to get that information, we go to this location. It's in the software hive. You go to Microsoft Windows NT, current version, network list, and there you will see something called profile. In there, for each profile again has a unique GUID, which you can use for get more information again. In there, you can get last connected date and time, and also the connection name or the profile name. Once you got that information, you will be able to identify the MAC address of the machine, MAC address of the particular network interface by going to this location. Again, you need to have the GUID. The folder has the GUID itself. So once you identify the GUID for the correct profile, you match that GUID, and then you can get to know the MAC address of it. Getting the MAC address is important because MAC address has two parts. First part is unique to the vendor. So once you when you're looking at a MAC address, you can identify what is the manufacturer. Or it can be a Dell, it can be a HP, it can be Intel. There are a lot of MAC address lookup search available on internet, and the latter part is unique to that particular network interface. And I will talk to you about an example. We received a case where an employee has deleted some of the important data of the company, and this company is doing an investigation on that, and the suspect is claiming that he didn't do it, and he said that he was on a vacation in down south on a hotel, and the laptop came to us, and then we did the investigation. We were able to identify the network profile that the user connected, and we got the deletion time, and that was reflected in the time period, in the least obtained time and the termination time period. That time was between that, and then we correlate it with the particular hotel, and we cross-checked and we identify the profile name, which is matching the profile that we have founded on his machine. So obviously he was on a vacation, but he carried the laptop and he used a hotel's access point to do the deletion. So depending on the investigation, depending on the case, you might get information from the registry. So that's one example. The next one is tracking user activities. So our goal is here to identify user behavior. Let's see how can we do that. There's something called MRU, which is stand for most recently used. That is available on the ntuser.dat file, because ntuser.dat file contain user specific data. Again, as I said, mentioned earlier, it will locate at root of each user account on the system. So to get information about typed URL using Internet Explorer, this is the location. Obviously, there are very few people who are using Internet Explorer, but I forgot to put that here. But there's a specific place for in the software hive. If you go to Google, if you go to Chrome, for the Chrome, obviously, there will be a specific place in the registry where you can find history and where you can find the typed URL there. And then again, you can there's a specific place where you can find recently opened documents. Again, it is in the ntuser.dat file. If you go to software, Microsoft, Windows, current version, Explorer, then the recent documents. Once you go in there, you will find another record file called MRU list X. The responsible of this file is to record the order which the file was accessed, and each file number is represented in 8 bytes and hexadecimal format, so you need to convert it to 32-bit integer. And each file extension has its own folder, and it contains MRU list extension file and then the file name. So let's see how it look like. So I'm in the recent docs. If you go there, you will see folders for each extension. Once you select one, you will find MRU list extension, and if you select that, you will get hexadecimal view, and then you select them, and then you have to convert it to 32-bit integer. Once you do that, for an example here, the first highlighted area, once you decode it to 32-bit integer, it says 58. So the most recent what you call file or document is belong to the index number 58, but you can't see any 58 on this screen. But if I can, but the screenshot, it doesn't show 58, but that is the most recently opened document. Here, the next picture, the second picture after here, here you can see the 58. And if you select that one, it says the file name. Again, it's a link file. Link file can be a shortcut. So this is the mostly recent file that the person has used to open. And first recent 10 documents will be displayed in the recent docs, and others will be divided into extensions. So here you can see there's a folder for PDF extension, there's a folder called for PPT, so on and so forth. So every folder again has MRU list X, which record the order which the file whatever records the order which file was opened. And then there's another one called use assist keys. Again, this will show most frequently open exe files and also link files. This is the location. It's ntuser.dat again, software, Microsoft, Windows, current version, Explorer, user assist, there's another GUID, and then the count. So once you go in there, all the informations are encrypted using ROT13 algorithm. So that means every alphabet, every character in the alphabet is replaced by the 30th relevant character. Let's see how it looks like. And before I go into that, Ncase has an nscript which it decode that information and provide the user a better view. And there's another tool called user assist view. It's free, and if you are doing an investigation on a running machine, you can use that. So let's see how it looks like. This is this picture will illustrate how you're looking at using a forensic tool. Again, if you particularly see the 90 index number, the value, you can't read it, but if you decrypt it using ROT13, you can say the file name is oinstall.exe. RKAR is basically EXEs. And to get last in timestamp about this particular exe, you have to use the ncase end script, or you can use the user assist view, which I mentioned earlier. So this is how it look like. You can get the name and last time the application was run. And this is the user assist viewer. This is basically, again, if you're doing an investigation on a running machine, you can use this. You can get the even the count, how many times this particular exe or the link file was used, and again, timestamps. Then another one called run MRU. This will save most of the commands that you put it in the run shell in the Windows. You can get the run shell using when you press the Windows button, and if you type run or Windows R, it will pop up, and whatever the commands that user has entered will be showed here, and there will be again MRU list which shows the order. And if you see the example here, you can see the command as well: explorer, regedit, cmd, gpedit. These are some of the commands that the user has used using the run shell of the Windows. And there's another specific place we call OpenSave most recently used, or OpenSave MRU. Again, that can be found in the below location. Any file that has been opened or saved using this Windows shell dialog box, that information will be saved here. Again, if you go there, each extension have a folder, and each folder has a file which tracks the order, and then that folder will contain most 10 recent files, regardless of the file extension, file name, and the location where the file is. And the next one is this is how it looks like. Let's say in a Windows environment, you can associate an extension with an application. You can, a user can specify, let's say a doc file can be opened using a word processor application. If word processor is not there, you can choose another application. Or let's say if there's MP3, you can play MP3 using a specific media player. That information again saved here in the ntuser.dat software Microsoft Windows current version Explorer file extension. It tells the system what application used to open the file, and then each extension has a folder, and again every folder has a MRU list. That list has an order of application. Let's say if WinWord is not available, the next best application is to open using a let's say Notepad or something. So here, for an example, doc file, any file that has a doc extension can only be used use winword.exe. So this is important to identify the user pattern or user. Let's say if when an investigation, if you find across extension that is not famous, or that's something that's not familiar, you can go here and there will be a folder for that extension, and then you can see which application used to open that particular extension. So that is important for the investigator. And again, we are at the end of it. What if there are no values? Again, there is a famous saying absence of evidence is not evidence of absence. If you find nothing, that doesn't mean there is nothing. There will always be something. Now, for an example, we had a case where the user has deleted the registry, and we were not able to find some key informations. But we were able to identify a tool called Windows Washer, and that particular software is used to remove Windows registry entries. So last runtime of that particular software became an evidence. So again, if you find nothing, you will find some sort of traces or some sort of evidence which can help the investigator to clear the to get more picture or get the nature of the investigation. So that's it for today. I know there are a lot of locations in the registry, lot of decoding mechanisms, but I believe we can share the presentation with all of you so that you can leisurely go to these location and do your own learning. And so I hope the presentation will be available for you. So that's it for today. So I'm open for any questions.
Ravindu, there's one question from the participants.
Okay.
What is the time period that we can see the MRU list?
The time period, you will not get the time period, but you in MRU list, what you get is the order. Let's say what is the first file, or the not the first file, what is the latest file that this person has opened, and then what is the next file, and then what is the file after that. Likewise, you will get understanding the order of the files that the user has opened, but you will not get the time frame. I hope that helps.
So, ladies and gentlemen, if there's any questions, you can type in the chat window.
Again, if you want to look at the timestamps, well, obviously, you have the image of the hard disk. You go to that particular file, and then you can get the embedded metadata, and then you can identify the creation time, and then modified time, last access time, all that information from there. If you have the file, you can get it from there. If not, if the person has deleted that particular file, you can get an indication from the registry. There was a file that user has opened, but it is not available in the hard disk physically.
Yeah, I know there was a bit of a confusion on the registration URL, and on behalf of the chapter, I'd like to apologize for that. Those who joined late, don't worry, we'll be sharing the recording of the event, so you can leisurely go through it. We can take few more questions if there are any.
Some people may ask, even I explained it earlier, why do we need to go through all of this if the tool we can use the tool to get it. But again, I tell you, there are instances where your output questioned by other experts, and if you fail to provide the information, whatever you produce in an investigation report or the incident, it will be it will be it will be questionable. So having a tool is good always, but having the knowledge where this information is coming from, it's always good.
There's one more question. Will you be able to share the methods of recovery if a suspected user has deleted the evidence?
Yes, I can tell you. Well, basically, when someone deletes a file, well, this is again depending on the file system. For this instance, I'll focus on the NTFS file system, which is New Technology File System, which is used on Windows operating system. There's a file called $MFT master file table, which keeping the information about all the files in the particular file system. It's like it act as a table of content on a book. It contains the file name, where the file is located, the physical places of the clusters, what is the starting cluster of the particular file, what is the ending cluster of the particular file, and whether those clusters are allocated or not. When a user delete that file, the record that whole allocation of clusters says unallocated, so that it show the user the space is available, but the file itself will be available there, right? That's how recovery tools are used. So what the recovery tool do, it goes through the MFT master file table, it goes through all the files and go to the starting cluster and ending cluster and try to retrieve it. There are chances, I think many of you have experienced this as well. You will recover same file twice because there are tools that read the MFT, and there's another file called MFT mirror, which is the backup of the MFT. So the tool sometimes use both files, then you will end up getting duplications. So that is how it recover. When you delete something, it will not go out. Only the record, it says those clusters are available. That's it. When someone put another file, you can't control where the file goes. Accidentally, let's say that file goes to those locations, those clusters, then the file will be overwritten, of course. If the new file is bigger than the file used the previous file, you will not able to recover anything. If the new file is smaller than the previous one, there are chances that you can get a fraction of the previous file. We call it RAM slack, we call it a file slack. There are a lot of things, but this is how it technically happens. This is on an NTFS file system.
Sure. So thanks a lot, Ravindu. Yeah, so thank you very much for the in-depth discussion on Windows forensics investigation. I think all of them who joined would have definitely been benefited by the insights what you shared. So let me share one more slide. Yeah, so we have Yeah, so we have an upcoming event day after tomorrow, not a very long time. So this will be completely on Teams. We will not have any hiccups. So I would urge all those who have joined today. This is an international speaker from UK. This is actually part of One in Tech initiative. We have something called She Leads Tech, where we encourage women participation in cybersecurity and audit. So as part of that initiative, we have an event on secure your business with a strong incident response plan. So again, it will be a very insightful presentation, and I would like to welcome you all. Thank you very much, all of you, for joining and listening to this webinar. And please support us by joining for future events as well. Thank you very much. Stay safe, and thank you. Good evening.
Thank you. Good evening.